This is 1-2, measuring and constructing segments. Go ahead and try the warm-up. Hit pause, and then while you do that, and hit play when you're ready to see the answers. Okay, here are the answers to the warm-up. So number 1, 17. Number 2 is 12. Number 3 is absolute value of -8. Remember, that's going to come out as positive 8. Number 4, x equals 2. Notice that I checked my work. I plugged the x back in and it worked. Number 5, x equals 5. And number 6, if you were in my class last year, when numbers fall in between each other, if you graph it on a number line, you'll see that that's an intersection. And an intersection is what I made up last year. It's an intersection for an and compound inequality, less than, intersection. So I have my small number. This might be confusing if you weren't in my class because I'm not sure how you were taught it, but small number is less than x, which is less than the big number. So I'm writing it as a compound inequality with less than. So absolute value is the distance a number is from 0, and that's why it always comes out as positive. So in that last example, we had absolute value of -8 in the warm-up, and that came out as positive 8, because I'm asking how far away is -8 from 0? 8 spaces. Just like if I said how far away from Disney World you live, nobody would say I live -100 miles from Disney World, because distance is measured as positive. You would just say I live 100 miles away from Disney World. So it's the same thing with distance on a number line. You can use a ruler to measure, or we can use our number lines or coordinates to find the distance between those as well. But the distance is going to come out positive. So find each length. The length of BC. Well, BC has a length of 2 units. So I can just calculate 3 minus 1 to find the difference of those two. Now for AC, that would be, if you count, 1, 2, 3, 4, 5 units. Or you can take the absolute value of 3 minus the other endpoint, -2, which becomes absolute value of 5, which is 5 units. Okay? And the 2 units, we could have calculated C minus B. 3 minus 1 is how I got 2. Okay, this is a big word we use often in geometry, congruent. You definitely want to know this one really well. So congruent segments are segments that have the same length. And we mark that using this tick mark, this red congruent symbol right here. That's telling me that they're the same length. So I don't have to take out a ruler and measure it because I just know that they're going to be the same length. Instead of an equal sign, when we write that a line segment is congruent to another line segment, we say that PQ, line segment PQ, is congruent to line segment RS. So congruent is an equal sign with that little tilde on top of it. For those that take Spanish, you've seen that before. And it also looks like the approximate symbol, but it's only one of those squiggly lines. Okay, segment addition postulate. Segment addition postulate says if you take 2 segments, like AB and BC, then it adds up to the total segment of AC. So the 2 parts add up to the whole. It would be like if I broke a candy bar in half, the half and the other half make the whole candy bar. You just add them together. So let's see what's happening. G is between F and H. So I'm just going to sketch this. G is somewhere in between F and H. This is not drawn to scale. FH, the total piece, is 11. FG is 6. So we want to find GH. This is G. Don't want you mixed up with the 6. Okay, so we're trying to find right here that GH. So I could say 6 plus whatever GH is. We can call that X if we want, or we can label that GH is equal to 11. So to figure out what that is, we subtract 6 from both sides, and GH equals 5. That one I know you could do in your head, but I just want you to be prepared for one that you might not be able to, like this next one. So my 2 pieces, NM and MO, add up to the total. So 17 plus 3x minus 5 has to equal the total, 5x plus 2. So now I have some solving to do. I can combine like terms, 17 and negative 5. That's going to get me 12 plus 3x equals 5x plus 2. And I can move the x whichever side I want. So 12 equals 2x plus 2. Now I need to get x by itself, so I'm going to subtract 2 from both sides. I get 10 equals 2x. I'm just going to bring that up here. So it was 10 equals 2x, and now I'm dividing both sides by 2, and so therefore x equals 5. And we could check to make sure that that makes sense. If you plug 5 in right here, you would get 3 times 5 is 15 minus 5 is 10. So I should get 27 then, because 17 plus 10 is 27. I need to make sure that this equals 27. So I put the 5 in that I got for x here. 5 times 5 is 25, plus 2 is 27. So the good thing is you could check your work on those. Okay, some more important vocabulary. Midpoint. The midpoint is the point halfway between the points. So if we're talking about midpoint of segment AB, then there'd be a point halfway between A and B. Middle, midpoint. Another way to say this is that the M bisects the segment. Bi is 2, so it's splitting into 2 equal parts. So it bisects the segment between points A and B. Example 4. The map shows the route for a race. You are at point X, 6,000 feet from checkpoint C. 6,000 feet from checkpoint C. The second checkpoint, D, is located at the midpoint between C and the end of the race, Y. So if D is the midpoint, then it's creating 2 equal parts. It's bisecting. So remember, I can write those congruent pieces with that tick mark. I'll write it better. So I know that CD and DY are equal to each other. The total race, this whole race from X to Y, is 3 miles. Well, 3 miles, let's think about this for a second, because we've got feet and miles here. That's no good. We can't have these 2 separate units. So if 6,000 feet, if we have 3 miles and I need to know how many feet that is, I need the rule between feet and miles. So I'm going to take my original 3 miles and I'm going to multiply that by miles on the bottom, because I know they need to cancel, and feet up top. So I need my rule. 5,280 feet are in 1 mile. So therefore, this 3 is really over 1. So I'm calculating 3 times 5,280, which is 15,840. So if that's easier, I can just change this to 15,840. Okay, and I'm trying to find how far apart the 2 checkpoints are. So what are these numbers? I can call them X and X because I know that they're the same. So basically I have 6,000 plus X equals 15,840. And now I can combine like terms. 16,000 plus 2x, not x squared, it's 1x plus 1x, which is 2x, equals 15,840. Subtract 6,000 from each, and I end up with 2x equals 9,840, and divide that by 2, and I get x equals 4,920 feet. So this one would be 4,920, this one would be 4,920. So how far apart are the 2 checkpoints? They're 4,920 feet apart. Okay, and a segment bisector is any ray, segment, or line that intersects a segment at its midpoint. So again, bisector. Segment bisector is splitting a segment at its midpoint. So if D is the midpoint of EF, so notice I'm drawing a picture here. D is the midpoint. And ED they're saying is 4x plus 6. And DF is 7x minus 9. Well, the midpoint is the key word. Why would they tell me that it's the midpoint? Because I know that it's making 2 congruent pieces. It's a segment bisector. So now, since I know these are equal to each other, I can set it that way. 4x plus 6 equals 7x minus 9. Negative 3x plus 6 equals negative 9. Subtract 6 from both sides. Negative 3x equals negative 15. Divide both sides by negative 3. And x equals 5. And we can check our work. So if you plug that 5 into both of these, on the first one you get 4 times 5 is 20 plus 6 is 26. And on the next one you get 7 times 5 is 35 minus 9 is 26. So they do equal each other, so that was correct. And they want every segment's length. I wasn't reading that. So find ED. Well, ED is equal to 26. DF is equal to 26. And EF, was that whole piece, would have been 26 and 26, which is 52.